Afternoon, everybody. My name is Niall Downey. I spent the last 10 years with a group called Framework Health, which is basically a group of aviation professionals sharing our aviation safety approach to healthcare, hence the name Framework Health. I'm contactable via Twitter and LinkedIn. We also have a website, and there's direct links on that to my email if anybody wants to get in touch to follow anything up afterwards. Why am I speaking to you? I've actually spoken to quite a few of you before. I think I spoke at your last live conference in London back a couple of years ago before COVID. My background is that I'm currently an airline captain with Aer Lingus. I'm captain on our European A320 fleet and also on our A321 Neo transatlantic fleet. Prior to that, I was a cardiothoracic surgery registrar. I trained in medicine in Trinity College in Dublin. Qualified there in '93 and then moved to Belfast for the Belfast surgical rotation. I got my fellowship at the Royal College of Surgeons there in 1997. I went back to Dublin at that stage to the National Cardiac Unit, but at that stage there was a shortage of specialist registrar training posts. So in 1999, I've left with no option but to jump ship, and I retrained with Aer Lingus as an airline captain, and I've been there ever since. So I don't think I need to convince you guys of the benefits of simulation. So what I propose to do instead is have a look at where simulation fits in to our overall safety framework, and also have a look at how we decide what to simulate and what to train. So the big difference, I think, between aviation and healthcare, having worked in both, is culture. Unfortunately, healthcare hasn't really moved on from the name, blame, shame, and retrain culture. Whereas in aviation, for the last 40 years, we focused on what's called the just culture. That means we can safely put our hand up and acknowledge error without fear of disciplinary action or dismissal. Now, just to be clear, it's not a no blame culture. That's a common misconception. If we make a mistake, we will be blamed. But the difference is if we admit to it and help with the investigation, and it wasn't either deliberate harm or gross negligence, there will be no disciplinary procedures. We then have a look at the incident and drill down into what actually happened. We usually find there's a problem with one of our systems. The individual involved has probably carried out the same procedure thousands of times without any issue. So what happened this time? We usually find that there was a tripwire that they fell over, and we try and engineer that tripwire out of the system and replace it, if possible, as a safety net to try and reduce the chance of the same incident or accident happening again. Finally, our crew resource management is our overall operating philosophy. This basically accepts that error will happen, and we try and train staff accordingly. Now, CRM was brought into healthcare maybe about 10 years ago, but it was rejected because personally, I think it wasn't trained properly. It was transplanted in and wasn't a good tissue match, so it got rejected. I think we need to genetically engineer it in. The underlying DNA, I think, is very sound, but it's not a direct transfer. But I think we can share a lot of our principles, and there's a lot of relevant skills which I think can transfer into healthcare if transferred in the right way. So as to say, our culture is we accept error as normal, not something to be ashamed of or vilified. We dig into our systems to find what went wrong and try and correct them. And we train staff to manage error. We expect it to happen, and it's no surprise when it does. We can simplify our whole system down to 2 steps, really. It's basically, where can this go wrong? And what's plan B? We always try and have a procedure in place that we can default to without having to try and work it out from first principles, which is difficult when time is very short, which it often is for us, even more so for you guys. Secondly, we also need to consider what's in it for me. If we come up with a system or a resolution which makes things harder for the staff member, chances are it's not going to survive long term. This is an issue I find happens a lot in healthcare. Checklists, for example, were engineered into your system, but in a way that just increased the bureaucracy without really benefiting yourselves. I think that needs to be looked at. And I think aviation has a lot we can contribute to healthcare to help with things like that. So our big issue is information sharing. We share information in lots of different ways, both voluntarily and involuntarily. Our airplanes have a telemetry system similar to Grand Prix cars. If anything goes wrong in my airplane, it comes up on my electronic central aircraft monitoring screen, my ECAM screen, and lets me know. It also comes up more or less simultaneously on our headquarters in Dublin and also in the Airbus factory back in Toulouse, so that several groups are aware that an issue has happened and can be looking into it and working on it in real time while the event is still occurring. Beyond that, we have an ops monitoring system. A lot of our information, both by telemetry and more detailed once on the ground, gets transferred into an overall centralized monitoring system in Dublin, where we can dig into individual flights. We have parameters built in that if they're exceeded, they flag up, so we can look at those flights. We can then see if it's a trend happening across the whole airline and decide, is it something that needs to be trained in the simulator every 6 months or in our annual recurrent training. Beyond that, in the event of an actual accident, we can look at the black box recorder and the cockpit voice recorder system to try and work out what happened and try and prevent the same issue from happening again, to try and intercept it and prevent it becoming an incident or worse, an accident, which can cause the loss of the airplane and obviously loss of lives. It also has a very detrimental effect on the actual company. So management are very invested in this as well. There's something in this for everybody, as we say. This is all part of our safety reporting system. If there's any issues happen, no matter how small, we can report them to our safety office. There's a number of ways of doing it. We can report them in real time using our iPad system and our onboard Wi-Fi. We have our telemetry and ops monitoring system, which I've already explained. We can send an email on the ground. We can ring the office, or we can send in an anonymous sort of hard copy, although very few people I'm aware of send in anonymous stuff. We're all quite happy to just put our hand up because we've seen that the just culture works for us. This information is then used to create an incident feedback booklet, which comes out once a month. It now comes out online. It gives details of all the incidents that have happened in the airline over the previous month. Digs into them in a bit more detail, takes out any learning, some material we can use from it, and then looks across the industry generally for anything that's happened in the recent past, which we can use to learn from to try and reduce any incidents in our own airline and improve our safety record. This is all used then to produce specific realistic training, which is where our simulation comes in. Simulators are very expensive bits of kit. They cost about $20 million each, and they're fairly expensive running costs. While we're being trained, obviously we're not generating revenue for the company either. So it's very important that any training we do is cost effective. A couple of years ago, I was on our Boeing 757 fleet, which was used on transatlantic routes. It normally landed back in the Dublin or Shannon at around about 5 or 6 in the morning, so usually about dawn. This is our simulator in London, which we used to train, say, landings into Shannon. We can see the westerly runway ahead of us. We can see the Shannon estuary. Beyond that is the industrial estate. Just to the right of the runway is the Lufthansa hangar, and just to the left, we see the aircraft buildings. We can create this in a fair bit of detail. It's in using our simulator. It's the far one there in a training area in London. Our Airbus training is done in Dublin in our own simulators. Inside, we can create fairly accurate graphics and very detailed sort of scenarios. It uses the same software as the plane does, and it's updated with the same regularity as the plane. We can see our parking area in Dublin here. It has our airplanes, and in the distance, it even has the Emirates 777, which parks there every morning. It's updated to that level of accuracy. So here's me in our Airbus 320 simulator doing my conversion a couple of years ago. This is a bit of training which has come from the Air France AF447 accident in the Atlantic back in 2009. We're now trained how to put the airplane into fairly extreme situations. That accident happens due to an upset which the pilot failed to recover from. It's now led to global upset prevention and recovery training, UPRT training, which we now do every 6 months. If you look at the horizon through the window, you can see that the plane's at a fairly extreme position there. We put the plane in extreme banks, extreme moves up, extreme moves down, combinations of that, and learn how to recover from that to try and prevent the Air France accident from ever happening again. The black box wasn't found for over 2 years, but going on the telemetry system that Air France and Airbus had available. They managed to recreate what they thought had probably happened, which turned out to be quite accurate. And we were training this in the simulator within weeks of the accident happening. And Airbus had put out the training material to all Airbus operators globally within weeks of the accidents happening. That's how fast we recover to accidents. I think you'll agree in healthcare, it usually takes a little bit longer. Give an example of our training. This is an Airbus A330 door, with an issue a few years ago, which our reporting system showed that cabin crew were having issues of opening doors and forgetting to disarm them, which meant that the slide deployed. This could cause injury to the air bridge operators on the outside as the slide deployed up the jet bridge. And it also put the airplane out of operation for several hours while the issue was resolved. So we now train specifically for this, but rather than take an airplane out of operation for it, we have a door simulator. Here's our A330 door simulator in Dublin. Our A320 has a slightly different door, so it has to be trained separately from the A330. We have it incorporated into our overall cabin trainer, which we use on an annual basis for training pilots and cabin crew together. Recently, we bought a new A321neo aircraft, which has a slightly different type of overwing exit. So again, we have a different simulator for that to train opening that exit specifically. There's different failures can be incorporated into the door training. Automatic sort of door opening can fail, hydraulics can fail. So we can actually pick what failure we want and train that specifically so that we're prepared for any event that actually happens on the real airplane. One of our biggest fears on an airplane is fire. Here's an A320 cabin. And of course, that's not what it looks like when it's on fire. That's what it looks like when it's on fire. So every year we train filling the cabin full of smoke. So we use dry ice. We train having to put on a smoke hood and find our way to the front of the cabin, find the doors and open the doors. We also train trying to find the various exits. As you see, the overwing exits are marked. We also have indicators on the ground for overwing exits, and we train how to find passengers who have been overcome by smoke and learn how to evacuate them. We then open the door and learn how to evacuate down the slide once a year so that we're familiar with the procedure. You may be aware that in Aer Lingus, we name all our aircraft after saints. We also apply the same principle to our artificial airplanes. Our A330 is a slightly bigger airplane, so the slide obviously is bigger and is higher. So we have an A330 slide, which is incorporated into our training area as well. And once a year, the A330 crews practice evacuating down the slide. As I say, one of our biggest fears is fire. So we have a new fire training facility we designed a couple of years ago, made out of a couple of shipping containers, basically. We learn now how to fight fires such as a waste paper bin fire if somebody's left a cigarette butt in after smoking in the toilet. We learn how to fight fires in overhead lockers. And we learn how to fight fires in ovens, amongst others. And the reason we do this is that it does actually happen in real life. This is one of our A330 aircraft in Orlando back about 3 years ago, where the unloading device taking the bags off actually caught fire and partially set fire to the aircraft itself on the ground. That led to some severe injuries for the loading crew, unfortunately, who were trapped inside, and also led to the aircraft being out of operation for 4 to 5 days in Orlando. So as well as for safety training, we also simulate basic training. This is our A330 simulator now, which is used to train our new cabin crew in basics or cabin service techniques. It can be observed from the inside, and we have windows on the outside, so the cabin crew trainers can actually observe from different angles while training the crew how to operate. As you can see on the inside, it's quite detailed. We can simulate service in our first class cabin here. We also have an economy cabin to simulate service there. This saves having to take a $250 million airplane out of service purely for training. So does our system work? Here's figures of aircraft accidents and incidents over the last century. Basically goes back to about 1910, and this takes figures up to about 2010. As you can see, there's a steady climb in the number of incidents and accidents up to about 1977, bit of a blip for the Second World War. If you factor that out, there's a steady climb up to 1977 and a steady drop since. And the number of deaths shows a similar trajectory. That's when we brought in our overall safety management system. We increased our amount of simulation training, and we basically learned how to deal with the error at that stage after the Tenerife disaster in 1977. Now, the amount of aviation has increased 15-fold since 77. We had about 3,000 deaths a year back then, so we should now have about 45,000 deaths per year if we had followed that trajectory. We actually have less than 1,000. So we think our system works fairly well. Let's compare that to healthcare. Here's figures come back over the last 50 years, looking at adverse events. It's accepted generally that about 10% is the standard figure for adverse events in healthcare in our hospital system. And as you can see, this hasn't really changed in the last 50 years. Here's one of our most recent studies in the Royal College of Surgeons in Dublin, published in 2015, Dublin's figures from just a little before that. It shows that, it's quite a busy slide, but it showed that about 12% of admissions had an adverse event. So we're in again around about the 10%. And the interesting figure at the bottom there is about 70% of these were considered preventable using aviation type techniques. So I think that a lot of our stuff could be transferred into aviation, or from aviation into healthcare, and that we could contribute quite a bit to healthcare safety if given the opportunity. If you want to find out a little bit more, there's some information on the website. And as I say, with all the contact details there if you want to ask any questions or follow anything up. So thanks for your time today, and look forward to hearing from you.